The title is Mid-Infrared Passive Spectroscopic Imaging for Non-Invasive Blood Glucose Sensor from a Distance. We developed the palm-sized mid-infrared spectroscopic imager using uncooled microbolometer array sensor. As you know, the uncooled microbolometer array sensor is used for thermography. In this case, we could acquire two-dimensional spectral distribution within 10 seconds. And also we constructed the peer-sized mid-infrared one-shot spectroscopy. The lens diameter is 6 millimeter and the optical path length is 15 millimeter. This apparatus could be built in smartwatch. This is Ichiro Ishimaru, Kaga University, Japan. And this study was published November 2022 in Scientific Reports. Title of this article is Glucose Emission Spectra through Mid-Infrared Passive Spectroscopic Imaging of the Wrist for Non-Invasive Glucose Sensing. If you are interested in our study, please download this article and read it. Scientific Report is open access journal, so download is free. As you know, the thermography detects radiated light emitted from body heat. Body temperature is around 300 Kelvin. This photo shows the mid-infrared image of human arm. Our question and curiosity is, radiated light include body components information like glucose. Thermography is based on Planck's law. Spectral emittance is determined by these curves. Human body temperature is around 36 Celsius. That is approximately equivalent to 300 Kelvin. These integrate value, area, is converted into temperature, and temperature is converted into false color image. This is thermography. Originally, this emission is derived from molecular vibration, and each molecular structure has specific resonant frequencies. The emission spectrum, due to the intrinsic vibration of molecules, has emission peaks for each component. So we expected internal body components like glucose will be estimated from emission spectrum. I'll explain about the differences between active and passive spectroscopy. Active spectroscopy is a general mid-infrared spectroscopy using light source. But for passive spectroscopy, we do not use the light source. Measurement unit detects the radiated light from object temperature. As for active spectroscopy, light source illuminates the target and measurement unit detects the reflected light from the target. In that case, molecular vibrations are excited by illumination, and light energies are absorbed as vibrational energy. Spectral absorbance corresponding to the molecular structure is acquired. But for passive spectroscopy, we do not use the light source. measurement unit detects the radiated light from the target derived from the molecular vibration. Compared with the active spectroscopy, at the same wavelength, I mean the lambda 1, lambda 2 in this case, we could confirm the emission peak at the same wavelength. So, active and passive spectroscopy has a negative and positive relationship. This photo shows a setup for non-invasive blood glucose sensor from a distance. We set the wrist at a distance of 600 millimeters from spectral imaging device. And these data shows the measurement results obtained from the subject. On the right-hand side graph, black solid line shows the spectral absorbance previously measured by the FTIR. We measure the glucose solution by conventional FTIR. In this case, vertical axis is absorbance, and we could recognize the specific absorbance peak at 9.25 and 9.65 micrometer as the absorbance peak. Red solid line shows the spectral emittance measured by our proposed method. At the same wavelength, 9.25 and 9.65 micrometer, we could recognize the emission peaks. So, active and passive spectroscopy has a negative and positive relationship. And this false color image shows the emittance mask whose wavelength was 9.65 micrometer. Mid-infrared passive spectroscopic imaging successfully detect glucose components from wrist. And we compare the time series changes of blood glucose concentrations between conventional blood collection type. This graph shows the measurement unit results taken every 10 minutes from 0 to 60 minutes with the conventional blood glucose sensor. And around 15 minutes, the subject drank drink containing sugar. At the time, blood glucose level gradually increase and increase from 100 milligram per deciliter to the 140 milligram per deciliter. This is the conventional method. And this false color image shows the emittance map, whose wavelength was 9.65 micrometer. And these numbers at the bottom of this false color image is the measured value by conventional blood collection type method. After drink containing sugar, blood glucose level measured by conventional method is gradually increase and increase from 101 milligram per deciliter to the 168 milligram per deciliter. And this emittance map changes to yellow. Yellow false color illustrates the higher emittance than green and blue. The emittance map changes to yellow as the blood glucose level rises. So we demonstrated the feasibility of non-invasive blood glucose monitoring from a distance. And the right-hand graph shows time series data of spectral emittance of subject. Blue solid line shows the invasive blood glucose level. And red solid line shows the emittance. Average emittance of 9.65 and 9.25 micrometer. These two graphs do not overlap because the unit of the vertical axis are different. But we could distinguish that there is a strong correlation between these two time series data. And we plotted all data on Parkes error grid. Horizontal axis shows the invasive blood glucose sensor. And vertical axis shows the blood glucose sensor that is converted from emittance using the standard curve. 91% data are in zone A and other 9% data in zone B. As for US FDA, if 99% of data are in zone B, the device can be approved as a medical device. However, the number of subjects must be increased. And we measured emission intensities of various body parts: iris, arm, forehand, back of hand. At every body pulse, we could recognize the emission peak at 9.25 and 9.65 micrometer. So we propose healthcare sensor casually watches over people with invisible light. AI speaker with built-in passive spectrometer will be set on the dining table. It will casually measure the blood glucose level of several people around the dining table simultaneously. And complementary, we wear the smartwatch for outdoor use. It is easy to integrate these healthcare data on the internet. If you are interested in a study, please download and read this article. Thank you very much for your kind attention.